Welcome all, welcome back at C-Square. In this lesson, we will talk about the building blocks of geometry. When you're going to have some things that we call undefined terms, we're going to define some terms using definition. We're going to see some postulates and theorem at the end of the lesson. Let's start with the first thing, where we have a point. A point represents a location, a precise location, like this one here. You see, this is point A. We name it using capital letters. The second undefined terms, a line is a straight path that extends forever in both directions. You're going to need 2 points to draw the line. Like in this case, you see you have the point A and B. By the way, this is the notation for line AB or line M, you notice. And like I said, you need 2 points. However, on this line, there are an infinity number of points. And you can name this line using any combination, by the way, not only AB. You can name this line BA, you are not going to be wrong. Array is a part of a line. Look at here, in this case, this is ray AB. You see the notation here. We have an endpoint. Point A is the endpoint, the one that you start from, and you notice in the notation you start with point A and then the other point, in this case B. We have an infinity number of points, and by the way, you can name this ray in many ways. Be sure you start with that point A in this case and get another point from that ray. Collinear points are points that are on the same line. You see here a good example. Points M, N, and P. These 3 points are on this line. R, N, and T, they are not on the same line. We can see that they are non-collinear. And let's see this first example. In this lesson, name some points, and if you say point A, that's you correct. Point B, yeah, see, anything you see here like a dot is a point. So you can list a lot more. I want to list 2 more points, which are M and N. Even though they are not, at least in this picture, they do not belong to any lines, we call them points. So that brings me to part B, because now we name some lanes. So can I say line AB? Of course you can. Don't forget to put the sign of a line. This arrow, with arrows on both sides, in fact. Can I call another line? Yeah, you are okay if you call that line BA, if you remember I said that a minute ago. But you can call that line also BC, you are not wrong. And guess what? There is another way to call that line. If you say CB, yeah, that's correct, but notice line K. Now, if you notice in that picture, we have another line. I'm going to use a different color, line T. Can I call it a different way? Of course, DE will be okay, ED will be okay. But also you can call it DF. So as you notice, more ways to name the same line. Name some collinear points. Can I say A, B, and C? Yes, of course. Let me put a comma here. A, B, and C are collinear points. Or what? Do we have another choice? Of course, we have D, E, and F. Name some points that are not collinear. I think the easiest one to see are M. And I can pick any other point on the line T, let's say D. And those 3 points, you notice, are not on the same line. We cannot connect them with one line. Can I get another one? I think I can. Let's say what? N, A, T. And like I said, you have many choices here to find 3 points that are not on the same line. Last part, name some rays. So what are some rays here? You can say DE. In fact, let me start with AB, since we start with AB. You see the notation, very important. The same ray will be AC. It's the same ray like AB, just use a second point, a different point C, to name that ray. Of course, we can move up on the other one and we say ADE is a ray. And let me be sure I talk a little bit about ED and DE, right? So DE is this ray, ED is the other ray. So you see they are not the same ray. That's very important to know. Together they give us the line T. In fact, they have a portion, they overlap portion. The segment D, we're gonna talk about segment later. My next part of the lesson, let's take a look to two lines. We have three choices. One, parallel lines. These two lines you see here are parallel lines. This is the notation. They do not intersect. The second choice is perpendicular line. We have it here. They do intersect and they form this angle, which is 90-degree angle. So whenever you see a box, that angle is a special angle, is 90 degree. We call them perpendicular line, as I said. And this third example, they do intersect. There is no special type of intersection. There is no notation, but they do intersect, and we have a point of intersection. Another building block of geometry is a plane. You have a plane in your picture right here. We call that plane R. You see the letter here, or plane ABC. Very important. These 3 points have to be non-collinear. They cannot be on the same line in order to name the plane. This plane goes forever, limitless, I said here. Okay. Of course, you don't have only those 3 points. You have an infinity number of points. You have also lines in this plane, like line AC, line AB, and obviously more than that. And well, the last thing, you notice how I drew this plane is like a shape, and this donut inside. Sometimes that's not the case, and sometimes you can use different shades of colors. You're gonna see in this lesson. I said here a plane contains line and points. There are points that are not in the given plane. Look at here. If we take a look to this picture, point R is not on this plane ABD. I'm gonna call it ABC. It's fine. Point P is not on the given plane. There are lines that intersect a given plane and lines that are parallel with the given plane. I think we can see the first one. You see this line, I'm going to call it line L. Intersect the plane at point B. Important part here, to understand, is that the dashed portion of the line cannot be seen, and then this is the line L. And like I said, there are lines that are parallel with a given plane. I don't have one here, but they do not intersect the plane, and that is the idea. Coplanar points, my next thing is are points A, B, and C. They are on the same plane, plane S, if you want to call it this way. D, A, B, and C, these one are not coplanar. You see point D is here on top of the plane. So in order to see non-coplanar points, you need to have 4 points, by the way, at least. Okay. Example, next example. Let's use this picture and answer to this part A through F. Name a plane that contains point B. See, point B is right here. What will be the plane? Plane R. Can I name that plane in a different way? Obviously, yes. You can use the point B, in fact, and say BEF. There are more ways to name the same plane, if you remember that. Name a line that contains point C. So we notice point C. See, what would be that line? DC. I can call it like that. And then you see it. C, it's part of the notation. Can I call that line in a different way? Yeah, line M. Find another name for line T. Let's take a look. Where is the line T? Line T is right here. What would be the other name? EF. Or FE. Part D. Find another name from plane R. We did that here. We said BEF, but let's have another one, just to have two choices. So we said BEF. Can I say EAF? That's correct. EAF. F, 3 points. The order does not matter, that's also important to remember. Part E, name the plane that contains line T and N. T and it's right here and it's right here. What will be the plane? Plane R. Plane R or any of these choices, right? Let me write one more time and let's write in a different way. F, A, E. Name 4 non-coplanar points, the last part of this problem. So let's name 3 points in this plane R, A, E, F, for example. These points are coplanar, and then pick one of them. One of these points, D or C. Okay? So these 4 points are non-coplanar. I'll give you one more just to be sure we have, and that will be, I will start to C, which is below the plane, the way we see it. C, B is on plane R, A, and let's say F. We have 2 examples of 4 non-coplanar points. I said here some figure contains more than one plane. Planes can be parallel like lines. When 2 planes are parallel, they do not have common points. The intersection of 2 planes is a line. So let's see here. These are the planes that do not intersect. They are parallel planes. These are the planes that do intersect, and you notice the intersection is this line. Very similar with 3 planes, obviously more than 2 choices. We have 3 parallel planes in this picture. They do not intersect, they have nothing in common. However, this is a nice case when 3 planes intersect and get a line. Okay, but also we have this situation when the intersection of 3 planes is a point. And another special case is this one where 3 planes intersect and every 2 planes form a line. Remember that. So we have here 3 lines. You can see them. That allows us to go to what I call is called 3-dimensional geometry. And for that reason, let's see what space is. Space is everything that is around you. It really cannot be shown in a lesson. Everything that is around you is boundless and contains lines and planes and points. So let's take a look here. Use the picture below and answer part A to F. You notice already a little bit different. We have 2 planes. Name a plane that contains line EF. Let's see what it's E and F. We see it, it's right here. Line EF is in plane R. Of course, you can use 3 letters to name that plane, but I'm gonna stay here. You may want to practice that. Name a line that contains point G. Where is that point G? Is right here. So the line will be DG. Of course, you can call it GD also. And you notice the notation. Name the point of intersection of line MB and plane Q. Line MB. And I think I have a problem here. I think I should have said HB. Let's do it this way. So this is the line HB and plane Q. This is the plane. They intersect right here at point B. Part D. Find another name for plane R. This plane R, like I said, you could have said that on part A, and I'm gonna just give you one option here, but obviously there are more than that. Oops. We don't really need to put a comma when you need to name a plane. So DCF will be good. Then let's go to part E. Name the plane that contains point C. Point C is right here. It's plane R again. name 4 non-coplanar points. We practice this. So pick 3 coplanar points like A, D, and you can say G, no problem, but let's have 3 non-collinear points, A, D, F, and 1 point that is not on that plane. H should be good. And a bunch of different choices here. My next part of the lesson will talk about what's happening in this three-dimensional geometry. Sometimes you have something that we call skew lines. So you see here we have, later we're gonna call this a rectangular prism. But I'm gonna say this one is like the space goes forever. Think about this cube going forever, not, and this being just line. This is the space, in other words. Name skew lines. Skew lines. Let's take a look. The lines that do not intersect, but they are not parallel. You see this? I'm gonna start with this. Let me be sure I use the correct color so you can see it. EF, and let's say this goes forever, right? Like I said, a skew line will be, for example, this one. CD. Okay, so you notice they are not perpendicular. They do not intersect. In fact. So EF and BC. Are those the only two? No, I'm gonna give you one more just to be sure you can see a different way. Okay, let's say you say AE. What will be a line that is a skew line? So you remember, it doesn't have to be in the same plane. Okay, and that will be DC. DC and AE are what we call skew lines. And there are more choices. Now, like I said a while ago, we talk about a segment or a line segment, and that is a portion. Let me erase the screen now. Of a line. So this is a line segment, the notation AB, and the difference between a line segment and the line is this. You can measure. You'll see that in another lesson. We can name it using 2 points, AB, only these 2 points, no other points. These are the endpoints. However, on this line segment you have an infinity number of points. Very similar with the line, you have more than 2 points, but we name it using 2 points. And this one is segment AB, and you are not wrong if you say segment BA is the same segment. Opposite ray, we talk about rays, but now let's see what opposite ray here are. We see here AB. See, this is the ray AB. And the ray AC. Oh, together they form the line AB. Yeah, that's correct. And they share that common point A. Let's take a look to this example where we have to name the segments in the figure. So let's name some segments. NM. Now remember, MN is the same guy. NT. Of course, TN, and we can name more than that. But remember, NM and MN are the same, however, NM and NT are not the same thing. Name the rays in the figure, so I'm going to use pretty much the same combination. This is ray NM, starts from N, goes through M. MN is another ray, total different than the previous one, NM. And NT. Can I name more than that? Of course. Okay. Name 2 opposite rays in the figure. So we're gonna have, for example, NM. Starts from, let's not start with this one, it's not a good example. Let's say the other way, in fact, MN So it starts from M, goes through N forever up here like this. And what will be the opposite ray? MT. Okay, so these are two rays. Let's say you want to do what I did. I'm going to say ray NM. Okay, very important. That is this one. In order to name an opposite ray, I have to put another point somewhere here. That will be an opposite ray. Let's call that point R and R. Just to be sure we see a different case. Last part of the lesson, you will see in geometry what is called postulates. You see them here. And theorems. And that's all for this lesson. Thank you.